Footage of Myanmar has brought the violent tremors of the earth into sharp focus once more. A magnitude 7.7 earthquake struck, leaving behind a trail of devastation. The Earth's crust hides forces capable of reshaping landscapes and rewriting human histories. This invisible threat beneath our towns and cities is a reminder of nature's unpredictable power. Earthquakes occur when energy stored in the Earth's crust is released suddenly, shaking the ground violently. Megaquakes, those exceeding a magnitude of 7.0, can cause catastrophic damage. These events are profound reminders of the planet's dynamic nature and the risk it poses to human life. The ground's violent shaking reminds us of our place on this ever-shifting planet. The 1960 Valdivia earthquake in Chile, the most powerful ever recorded at a magnitude of 9.5, obliterated infrastructure and claimed thousands of lives. These events highlight the awesome power of the Earth, compelling us to learn more and prepare better. The most potent quakes arise from convergent plate boundaries where tectonic plates collide. The Pacific Ring of Fire is a horseshoe-shaped belt of seismic activity encircling the Pacific Ocean. Here, the Pacific Plate grinds against its neighbors, creating earthquakes and volcanic eruptions. In the Alaska-Aleutian Trench, the Pacific Plate dives beneath the North American Plate, a process known as subduction. This zone generated the 1964 Great Alaska Earthquake, measuring 9.2 on the moment magnitude scale. This scale quantifies the energy released during these colossal events. Sumatra is another hotspot where the Indo-Australian Plate subducts beneath the Eurasian Plate along the Sunda Trench. The 2004 Sumatra-Andaman earthquake triggered a devastating tsunami, reminding the world of the interconnectedness of oceanic and seismic forces. These regions, marked by their tectonic volatility, are under constant watch for future cataclysmic events. Understanding earthquakes begins with the tectonic plates, massive slabs of the Earth's lithosphere driven by forces deep within the planet. These plates, in constant motion, interact at their boundaries, where stress accumulates due to friction. When the stress surpasses the strength of rocks, a rupture occurs along a fault line, releasing seismic waves that travel through the Earth. The point where this rupture initiates is called the hypocenter, or focus, located beneath the Earth's surface. Directly above it, on the surface, lies the epicenter, where the shaking is often most intense. As the energy radiates outward in waves, it manifests as the ground shaking that characterizes an earthquake. These seismic waves can travel vast distances, losing energy as they go, but remaining potent enough to cause damage far from the epicenter. Different types of seismic waves, primary waves or P waves, secondary waves or S waves, and surface waves contribute to the shaking. P waves, the fastest, compress and expand the ground, while S waves, slower, move it up and down or side to side. Surface waves, though slower, are particularly destructive as they cause the ground to roll, leading to severe damage to structures. The fury of subduction, specific causes and consequences. Subduction zones are the crucibles of megaquakes. Here, one tectonic plate dives beneath another, creating immense pressure over time. This process is responsible for some of the most powerful earthquakes in history, as the stress accumulated is eventually released in a massive jolt. The vertical displacement of the seafloor during these events can also trigger tsunamis, compounding the devastation. In the Peru-Chile Trench, the Nazca Plate descends beneath the South American Plate, a zone notorious for generating powerful quakes. The 1960 Valdivia earthquake exemplifies the destructive potential of these regions. The sudden release of built-up stress not only shook the land, but also uplifted the ocean floor, unleashing tsunami waves that traveled across the Pacific. The Sumatra-Andaman earthquake similarly demonstrated the dual threat of ground shaking and tsunamis. As the Indo-Australian Plate subducted beneath the Eurasian Plate, the resulting rupture displaced a massive volume of water, sending waves crashing into coastlines far and wide. These events underscore the need for vigilance in regions prone to subduction-related seismic activity. Chronicle of catastrophes, historic megaquakes. History is dotted with earthquakes of such magnitude that they reshaped the contours of human civilization. The 1960 Valdivia earthquake in Chile not only claimed over 1,600 lives, but also altered the geography of the country. Its immense power was felt as far away as Hawaii, Japan, and the Philippines, illustrating the far-reaching effects of these titanic forces. Similarly, the 2004 Sumatra-Andaman earthquake left an indelible mark on the world. It triggered a tsunami that swept across the Indian Ocean, affecting 14 countries and resulting in over 230,000 fatalities. The scale of destruction highlighted the vulnerability of coastal communities and the critical need for early warning systems. The 2011 Tohoku earthquake in Japan is another somber reminder. The 9.1 magnitude quake and subsequent tsunami devastated the northeastern coast of Japan, leading to a nuclear disaster at the Fukushima Daiichi plant. These events serve as powerful reminders of the potential for sudden and widespread devastation, urging nations to invest in preparedness and resilience. Safety in the face of chaos. Preparedness measures. Facing an earthquake requires preparation and resilience. Have an emergency kit ready with essentials like water, food, and a first aid kit. Secure furniture and heavy objects to prevent injuries. During an earthquake, drop, cover, and hold on. Move to an open area away from buildings and power lines. In coastal areas, move to higher ground to avoid tsunamis. Check for injuries, listen to updates, and avoid unnecessary phone use. Community drills and education campaigns are vital for preparedness. A future on shaky ground, embracing resilience. As our understanding of earthquakes grows, so too does our capacity to mitigate their impacts. Advances in technology have enhanced our ability to predict and respond to these events, but challenges remain. Building resilience into infrastructure, developing comprehensive early warning systems, and fostering a culture of preparedness are essential steps in safeguarding lives and livelihoods. Communities around the world are learning to live with the threat of earthquakes by embracing innovative solutions. From designing buildings that sway with the seismic waves to implementing public education programs, the focus is on reducing vulnerability. While we cannot stop the tectonic forces beneath our feet, we can certainly minimize their impact on our lives. Investing in research and development, strengthening global cooperation, and fostering awareness are key to a future where humanity can coexist with the planet's dynamic nature. As the Earth continues its ceaseless motions, we stand at the threshold of a new era, one where resilience and preparedness are our strongest allies in the face of Earth's fury. Thank you for watching. Subscribe for more videos.